Okay, we are talking about our first project. We are developing a trig table. All right, so there's this little blurb here if you want to read it about Icarus. I think that's how you say it anyway. And he was the first one that developed the trig table, yada, yada, yada. Okay, so let's go over what in the world you're going to do. Do you remember SOHCAHTOA, right? Right? Remember that magic word? And then you remember sine, cosine, tangent? So, for the sine function, I'll put the magic word here. SOHCAHTOA. So what was sine equal to? What over what? Do you remember? Yes, opposite side over hypotenuse. Cosine was equal to, what's the A? Adjacent. The adjacent side over, again, the hypotenuse. And then tangent, of course, is opposite over adjacent. All right, so you need those three ratios, okay? And then if you kind of read through these steps, so there's the first bullet. Write down the formulas for sine, cosine, and tangent. Boom, there they are. Second bullet, it says for each of the following measurements, draw a right triangle with one acute angle of that measurement. Make sure to use metric rulers and a protractor and be as exact as possible in your constructions. Make your triangles large, so about 2 per page, so that accurate side lengths can be determined. All right, so this is what you want to do. So you're going to have 1, 2, 3, 4, 5, 6, 7 triangles in all. And you're going to draw them. They're all going to be right triangles, but you want one of your acute angles to be whatever's there. So for example, if I was going to do this first one, that was a 5-degree angle, okay? I would start off by making a 90-degree angle, okay? Make it kind of nice and big. Make sure it's 90. Use your protractor. Okay, I have a 90-degree angle there. And now what I want to do is I want to make one of these. I'm going to connect this into a triangle, but I want to make one of these two angles 5 degrees. So it looks like I'll probably do this one. Okay, so I'm going to take my protractor. Remember how to use a protractor, I hope. So you put there's always a dot, a hole. So you put the hole over where you want it to be. Make sure you line up. There's a line that goes through the hole. Line it up with the line that you already drew. And then I want this one to be 5 degrees, right? So here's 0, 10, 20, 30. So I want 5 degrees, which is a little tough because I can't put a dot right there. But if I'm very careful, so now if I connect these, there we go. So there is my triangle. I don't need this part here. That has a 5-degree angle and a 90-degree angle. Okay? So there is the first of my 7 triangles. And then I would draw another triangle. Make sure that it has a 15-degree angle. 30, 45, and so on. Does that make sense so far? Okay. So you're going to have 7 triangles drawn really nicely. Be as accurate as you possibly can. All right? And then the next bullet says, for each triangle, label the side opposite, adjacent, and hypotenuse in relation to the acute angle. Okay, so here's my acute angle, that's 5. What side is this one over here? Is it the opposite, the adjacent, or the hypotenuse? If that's my angle, what's this side? Okay. Yes, it is the opposite side. I was just going to say, maybe I should draw a triangle that looks a little bit more like a triangle first. If I'm talking about this angle, right? Remember, you always have 3 sides. There's opposite, adjacent, and hypotenuse. Who's the hypotenuse? Maybe we should start there. The longest side, which is always located where? across from the 90-degree angle. In fact, that 90-degree angle points at it. So this guy is always your hypotenuse. Okay? Now the opposite side and the adjacent side, they change though depending on what angle you're talking about. So if I'm talking about this angle, the side opposite it would be here. So you'd be the opposite side. And then the side that it's touching, that's not the hypotenuse, right? Adjacent means right next to. So this would be the adjacent side. Do you remember that? Is that ringing a bell? Okay. And then just to reiterate, if I had the same triangle, but I was talking about this angle instead, well, the hypotenuse is still the hypotenuse. That never changes. So that 90-degree angle points right at it. That guy's the hypotenuse for sure. But now, what's this side? Now that's the opposite side, because it's across from that angle. So you're opposite, and now this side would be adjacent. So do you see how it changes depending on what angle you're talking about? So you always have to make sure that you're referring to the right ones. Does that make sense? Okay. So now if I'm looking at the triangle that I just drew, the super narrow one, the hypotenuse is going to be this guy, right? My 90-degree symbol is pointing at it. So that's the hypotenuse. This side down here, we already said would be the opposite side, right? It's across from that angle. So your opposite, and then this side back here would be the adjacent side. So for each triangle, you're going to label the three sides, and then you're also going to want to measure them as accurately as you possibly can, which is why we want to use metric instead of imperial, right? So measure your three as close as you can get, whatever they are, and write down what those measurements are. So that opposite side, I'm looking at point, let's see, 5, 6, 8. I would call that 0.8. So this side's 0.8 centimeters. And then measure your other ones, right? So you're going to measure all three, write down what they are. Here's where the cool part comes in. I guess I'll do one of them for you. Let me measure my hypotenuse. Let's see how accurate I did. I've got 8.9 for that one. So what you're going to do is you are now going to take the sine of 5 degrees is the opposite divided by the hypotenuse, right? Right? Everybody's with me? Right? If I go back to this ratio, it's the opposite side divided by the hypotenuse. So, sine of 5 degrees is equal to my opposite side was 0.8 over my hypotenuse was 8.9. You're then going to actually do that division and see what comes out. So the sine of 5 degrees comes out to be, let's see what 0.8 divided by 8.9 is. I got 0.0899. You're going to go out to 4 decimal places. I don't know if it says that on this sheet. But yeah, you should go out 4 decimal places if you want to just make a note. I'd put it right, yeah, right here on this bullet, 4 decimal places. Now, what's so cool about this, you couldn't even see. That 4th bullet, I would just make a note to yourself, at least 4 decimal places. Here's what's so neat about this. I can see how close I am to the right answer. I got that the sine of 5 degrees is 0.0899. If you just take this sheet and flip it over, I gave you a trig table. So if I look under 5 degrees, the sine, ooh, not bad. It should be 0.0872. I'm awfully close. I'm at 0.0899. So I'm off by what? 17 thousandths? I'll take it. That's not bad, okay? So you already have all the answers here. You know what the calculation should come out to be. It's so neat to kind of do it, though, and actually get those numbers. Right? So that's the idea. So then I only did sine. You're going to go ahead and do cosine and tangent and see how close you got for that. Does that kind of make sense? And then you do the same thing for the next triangles. all the way through, okay? So that's the gist, and then there are a couple of questions for you to answer. Where are they? Down in here. So I just ask you for a couple patterns. What do you see? It doesn't, I mean, a couple sentences, that's all I need. Just make sure that you answer them, because every year someone turns it in without answering any of the questions. I'm like, So I'm giving you, you're going to take your quiz tomorrow, and then whatever time you have left, you can get started. You have all day on Monday to get started. And I'll be here on Monday, so I can answer any questions too. So I'm going to make it due, how about Wednesday? So even if you don't finish it in class on Monday, you at least have a little bit of time that you could. And I might, oh shoot, I am not after school on Tuesday next week. I normally am. I'm glad that I remembered to tell you now. I have to stay on Thursday next week. But anyway, so let's have it due on Wednesday. So that day of the week is what? What's the date? Is that the 5th? Yeah. Due Wednesday, 2/5/20. Okay, does anybody have any questions about what you're supposed to do? I would think you'd be in good shape if you at least have your triangles drawn for tomorrow. And then you could do all your measurements. The questions shouldn't take you very long. No questions? We're good? We're all right? And everybody knows where to find all the things? You're welcome to, I mean, you don't have to use this paper, but it draws so nicely, so. I would use pencil, of course. Yes, you can borrow my mechanical pencils if you want to. Just please make sure you put them back. Okay? And like I said, rulers and protractors are over there. Alrighty? Okay, so